Hello everyone to this new video in our series about generative AI. In this video, I will be showing you a package for Java. It's called Llama3.java. Using this Llama3.java, we can load and use LLMs without any other external dependencies. So this is the repository for Llama3.java. Let me go quickly through the description of this repository. So as you can see here, this Llama3.java, it can be used to run Llama 3, 3.1 and 3.2 and is implemented in a single Java file. Also here they are showing us even the command to run it. And of course we use a model which is in the GGUF format as we have seen in the previous video. So this is a quick description about the project. So you can see there is a predecessor for this project which is Llama2.java here if you want to read about it. And this is based on this Llama2.c, which is done by Andrei Karpathy. So you can also go to the Llama2.c, and this is also a good project where you can run Llama using pure C language. So let's go back to Llama 3.java. So, and you can see also that this repository has an educational value. That's really true because this file contains a GGUF file reader and it can really run the Llama. And it's only around 2,500 lines with the comments and everything. And here are the features. So one single file, no dependencies. We only need GVM21. So it has a parser for GGUF format and it have a Llama 3 tokenizer, Llama 3 inference, and a whole other list of features. And it also has a simple CLI, which I will try to run now using the command line. You can also see here are some links for some videos about it. And here there are some links to download some modules in the GGUF format. So here we have the 3.2 Llama in 1 billion parameter, then 3 billion parameters, and then we have the 3.18 billion parameters. And then also some information about the quantize and then how you can build and run. I will not be building, but you can also try it using this command. What I will do here, I will try to run it directly from the source code using directly Java. And as you can see here, we need to enable preview and we need also to add a model from the incubator, which is this model Victor. This is what makes this package fast. That's using this Victor. So this Victor they use, it's called single instruction, multiple data. So you can read more about it in Wikipedia if you want, or you can search for other links on Google. So as you can see here, this single instruction multiple data enable parallel processing. Of course, it needs to be supported by the CPU. If it's supported, then you can run this file here very fast. So let's go back here to our command line. The last option here which we need to put is the model path. So we will use our GGUF model, which we fine-tuned in a previous video to answer the OA estimation questions. There is also here about the optimization and the GraalVM. I will not go through that. Then here there's the performance. I wanted to show you the performance figure that they have. Notice here they even showed that this Llama 3.java is faster than llama.cpp. So let's first clone this repository and try to run the command. I will use this link here and let me open a PowerShell. So in our repository here on my computer, I already prepared a folder for this video. So we already have a folder called llama.java. Inside this folder here, I have a Java project, which I have created using IntelliJ IDEA. So let me create a new folder here. I will just call it temp because I will delete it later. And let's step inside this temp. And this is an empty folder. Let's now clone the repository. So the repository is cloned now to this llama3.java. Let's step inside it. And now you can see that we have this llama3.java file. The other files are, as you can see, only get, ignore, license, makefile, and readme, which we don't need. So let me now copy the command line to run this file. So this is here the command line. Let me copy it. What we need to change here is the path for the model. I will copy the path for the model which we trained last time for the OA estimation. So this is the path. I put it inside our repo in models and it's llama 3.2 instruct DOA. So let's now run. So you can see the model is already been loaded and now we can ask a question. So what's music for direction of arrival estimation? And you can see, so music is a subspace-based method used to estimation the direction of arrival of a signal. So that's a correct answer. Like it's very short, but it's really correct. So it's a subspace method and that's true. So let's ask about Esprit. So it's telling us that Esprit uses the rotational invariance technique and it's based on the subspace also, so which is also a correct answer. So the model is working. So I will close this for now. And let me open the IntelliJ IDEA and the project which I prepared for you. So this is the project I prepared for you. So this project is built using Gradle, as you can see here. And the main file, of course, in this project is the Llama3.java. So let me open this file. I copied this file from the repository. So really here, the full credit goes to the authors. I will not change any line in this file here. I only put the source for this file so that you know where I download it. So from GitHub, Muckle, and Llama3.java. And you can see here it's also based on Andrej Karpathy Llama 2.c, as we've seen before. So this is the whole library. As you can see here in the imports, there's only GDK imports. There's imports from the incubator vector, and then from Sun, and then from Java, and that's it. So really no external dependencies. And if we want down here, you can see that this file is only 2,577 lines. That's including comments, empty lines, and everything. Here in IntelliJ IDEA and the project explorer here, you can also see the different classes and structure of this file. So you can see here something about the GGUF format, and you can see here also the main function, which is loading the model, which will take the model path and will load this GGUF file. And of course, you can go more in depth and see how they handle the float tensors and other kind of variables. I will not go through this. What I wanted to do is to go through the main function here. So here at the main function, so this function will be called with certain argument which we pass. So for example, the path to the model, and you can see here how they build options and then how they load the model, and then they select a sampler, and here they are running this either interactive based on the options which we pass. So I will go also inside now this run interactive, and inside this run interactive, you can see here is the loop where they look into the input which we give in the command line. And if we put /quit or exit, then they will exit. And then there's also some context if we want to give a context, and then how they add the tokens. And then as you can see here, how they generate the response. So here we've got the response, and then they decode the response and show the output, and then the loop goes back again. So I'm showing this because I will be taking something similar from this function and building a GUI interface for this llama.java. And that's what I did here inside this file main window. So now my main class, I will use this main, which only create this new main window. And in the main window, I will be using Swing. So I hope that you are familiar with Swing. And yeah, here I want again to apologize because I'm like keep jumping from programming language to another in each video. So we started by Python, then we went to JavaScript, and now to Java. But yeah, once you know one language, I think it will not be difficult for you to follow with the other languages. And of course, if someone interested in Java, then he can watch the Java videos, and yeah, same for Python guys or JavaScript guys. So you can see that the main window extends a swing frame, and then add to this frame a text pane. So that's for displaying the response. So this text pane, as you can see, I'm putting the content to be HTML so that I can output some rich text format to it. And then there is a text area here, which I will be using to input our questions. And that's it basically. Yeah, so here I'm like putting some default questions and so on. And then here I'm adding a listener to the on show. So because that on showing this window, I want to initialize the chat, and I want to add a key listener to the input area. So when we press enter, I want to take the text and use it as a question and forward it to the model. So that's done using this function chat here. So basically here there are two functions. So one to init the chat, and then one which we will call every time we press enter. So let's go now to the init. So in the init, it's the same code as before. I'm putting string options which we passed in the command line. I'm putting them here. So here I need to put the path to the model. So let me put the correct path here. So this is the same path which we used in the command line. And then here I'm adding also the other argument which we put in the command line. I'm also here using max tokens, 13,000. This is like very large. Maybe it's enough to put 2,000 or so. Then we are loading the model, preparing the sampler as we've seen inside this Llama3.java. Yeah, and that's it basically. Now, when this function is done, we have our model loaded, the sampler is initialized, and we can ask question. And that's what happened here in this chat. So in this chat, we will get the text from inside. So it will be called, as you've seen, when you press enter inside the text area. And this text here will be taken as the text from inside the text area, so which should represent a question. So then here I have like this print function. So this is just to show output. So this will print this text on the text pane. This is really a simple function here. It's just called this add text with a certain color, and we want bold or italic. And this add text is create a style document from the text pane and then put some attributes. So do we need bold, italic, color, and size, and so on, and then insert the text to this document. This is really just for outputting the text. And then here, as you can see, I'm starting a new thread, and inside this thread, I'm basically putting the same code which we've seen before inside the while loop here. So inside this run interactive, inside this while loop. So this is this code here. So we are encoding the messages, then we are generating the response. So really calling the model, and this will be streamable. So every time we get a new token, this callback here, this function callback will be called, and the response here is simple. We just output this new token into the text pane. Yeah. And that's it. So the rest is similar to what we've seen in the Llama3.java. So that's it basically. As you can see, it's really a small file, small GUI. Let me run it. Yeah, before I run it, I want to show you the options that I had to change. So here inside the Gradle build, I had to add this enable preview and to add also the vector model. So if you did not do this, then we will not be able to run the project. But now we can run, and as you can see, this is really the simple GUI. So this is here the text pane, and this is our text area. So we have question why the sky is blue. Click enter and look, the sky appears blue because of the way light interacts with the atmosphere. So it's really answering correctly. Let me show you also the performance here. So this is really CPU based, so focus on the CPU. And let's start asking now questions about DOA estimation. So now it starts telling us that the music algorithm is a subspace algorithm, and I hope that you've seen here the peak performance in the CPU, and the usage of the GPU did not change. So this is really based also on the CPU performance. So let's ask now about the spread. And you noticed also a peak here in the CPU, but in the GPUs, nothing has changed. I hope that you noticed that this is like really fast. And also here we got also the correct answer for Esprit. And yeah, that's it for this video. I hope you like it. And if you are really a Java programmer, then give it a try. This is a really nice library, as you can see, really based on the CPU and fast performance. And also for Java programmers, in the next video, I will be making a new plugin for IntelliJ IDEA. This plugin is an AI assistant, which will be used to generate functions similar to what I did before for VS Code. So if this is something which you may be interested with, make sure not to miss the next video. And see you then. Bye.